We're here at our at the thermal energy storage tank, and I've got three SMEs who are going to talk to you about what it is, what it does, and how it's helping us here at Kennedy, and about our partnership with Florida Power and Light. So first, you'll hear from Ismael Otero. He is our project manager from NASA on the thermal energy storage tank. And then Bert Gretchens from Florida Power and Light will talk to you about how it functions and what their partnership is and how it's generated a rebate check. And then Dan Clark is going to talk to you about programs that we're doing with the savings that we're getting from the tank. So I'm going to turn it over to Ismael, and he's going to start off.
Thank you, Brittany. Glad to see you. I know it's been a long day. You've already been through a lot, but a little bit more of information, including some technical information I'm planning to give you. Please keep your questions for the end after the three speakers, okay? And then we'll be happy to entertain your questions. Like Brittany said, I'm the project manager. I took over about a year or so ago on the project. And the project really was the industrial area chiller plant upgrade, which is what you have right here on the west side of you, to your right. And later on, a few months later, the project was blessed to have an addition, and that was the thermal energy storage tank. Now, how did this come about? Well, basically, one of our senior engineers, almost 10 years ago, said to an intern, young engineer, always people who are thinking outside the box. Isn't that great? I like that. He said, you know what? We need to take a look at a thermal energy storage tank. It may be something we could use in the future. So back then, this young engineer decided to make it his project. When you're an intern, you have to make a project. So he decided to make it his project, and he started running with it. And actually, that grew into a pretty good presentation to management at the end of his tour with us. Later on, that went on to become a study. Of course, at that time, we think big, don't we? I mean, we're NASA, so we think big. It was a 6 million gallon tank. Well, after many iterations and an actual design and limited funding, as usually it is with the government, we ended up with a 2.8 million gallon tank. So that's what we have here. The tank, as you see it today, is approximately 80 to 90 feet tall and about 78 feet wide. The tank, what you see on the outside really, is just foam painted with a little membrane on the outside. It's called an external EFIS, external insulation foam system. No, you cannot just puncture it with your finger because of the membranes on top of it. But that's what insulates the tank, because what you have inside the tank is cold water. They call it chilled water. And that's therefore because we have a chilled water system that actually cools all these buildings you see around here. So the Space Station Processing Facility, the ONC checkout building, the old headquarters building that is still active, and the new central campus, which will be the new headquarters building, all are also cooled by the chilled water plant right here. Okay, the industrial area. This is called the industrial area. You were before in the launch complex area. The tank itself is fairly simple. It's a concrete structure. They call it pre-stressed because they put this wire, this steel wire around it. It's kind of neat. You see this thing going around and around and around, putting a lot of wire all around the structure. The walls are about a little over 10 inches at the bottom, because that's where the pressure is, where a lot of the water is, no? The water pressure is. And then at the top is maybe 3.5 inches thick, okay? That's beside the insulation. I'm not talking insulation. Now, what does a tank do? Basically, a tank is like a battery. Just think of your battery, all right? It's a closed system. It is not that the tank is actually depleted of water and then filled with water, but it's a closed loop system. If you are discharging the battery, you're basically taking cold energy, you're taking cold water out and putting warm water through the top at the same time, okay? And we do that, for example, in the summer, what we call in the peak hour days, like between 12 and 6 o'clock in the evening. Those are peak hours. Why are they peak hours? Because that's when you pay peak dollar. Get it? All right, so in the winter it's a little bit different, and the hours change. But the concept is the same. During peak hours, you actually discharge the tank, because that way you pay less money for the energy you use. Because at night, for example, in the summer, you have to charge the tank. So you use the equipment that is in this chiller plant, chillers namely, to cool that water and feed it back again. In other words, charge the tank. All right, and the tank itself is a great addition, not only because it saves you money, but also because it enables the entourage of people that operate the plant to be able to do certain maintenance tasks where we could have done them before without what they call an outage, bringing down systems, see? Because when you have the tank, there's a number of systems that don't have to operate. You just discharge the tank of its energy and you keep the chill water loop system working. And they can do maintenance on a number of different pieces of equipment. So it's really actually a great addition that we've never had before at Kennedy Space Center. The project itself started a couple of years ago in terms of its execution, 2014. The tank was completed basically really in the March time frame, and then it took us a little bit of time to actually commission the tank, let's call it that. The tank has, throughout the height, a series of, let's call them thermometers, sensors, that are measuring the water temperature. And those are used basically to control where to we're going to do the discharge, to know how charged the tank is, etc., etc. And there are 20 of those, they call them thermal wells, if you want to be precise. But they're just sensors, they're thermometers. There is a control system here in the plant, so the actual operators, they don't have to go out there to do anything. You don't have to do any valving outside, you don't have to do anything manually. You can sit down at the console and operate everything through computers and big screens. So there is a fancy control system behind all these systems. I think that's one of the more challenging parts of it, really, is the control systems. The tank itself is something that is a proven technology that has been built in a number of other locations as well throughout Florida, and it makes a lot of sense to do it. I hope that we're able to build another tank like that at Kennedy Space Center. At this time, I don't know how much, I didn't ask how much time I had, so Brittany, should I go ahead? I don't know how much time I had. Okay, so at this time, I'm going to pass it on to our FPL representative, Bart, here, that was introduced earlier as well. Thank you so much.
Thank you, Ismael. Good afternoon, everyone. It's a pleasure to be here on behalf of Florida Power and Light Company on such an exciting week as NASA prepares for SpaceX CRS-10 launch. As Ismael mentioned, FPL has a long-standing relationship with NASA and the John Kennedy Space Center in our joint efforts towards sustainability and energy efficiency. In 2010, as part of our commitment to help move Florida forward to create a better tomorrow for all of us, using clean, renewable energy sources, we teamed up to provide America's space program and FPL customers with new sources of clean solar energy. Our joint venture, which leveraged the expertise of NASA, the first pioneers in solar use in space, and FPL's leadership in renewable energy here at home, including the completion of the Space Coast Solar Energy Center, a 10-megawatt photovoltaic power generation system. Built on 60 acres of land just south of here, the facility uses photovoltaic solar panels to convert light into electricity for our customers. Since it began serving our customers in 2010, the center has generated 18,500 megawatt hours of electricity into our state's energy grid each year, or enough to produce clean, emission-free energy for more than 1,000 homes. Like all of our solar energy centers, the Space Coast Solar Energy Center helps us reduce foreign oil use and prevent the emissions of about 13,000 metric tons of greenhouse gases each year, which according to the EPA is like removing 2,700 cars from the road. FPL is proud to be leading the growth of affordable clean energy in the southeastern United States, reducing emissions while keeping customer bills among the lowest in the nation. Last year, we installed 1 million solar panels, tripling our solar generation capacity. In addition, our commitment to clean, renewable energy sources, FPL has a proven track record of offering energy-saving solutions to help our customers save energy and money while providing reliable service and substantially reducing emissions. Understanding the Kennedy Space Center's desire to implement energy-saving measures in its facilities, FPL helped facilitate the installation of the new 2.6 million gallon chilled water thermal energy storage tank, which you see here behind us, right on cue, to keep their facilities cool and comfortable. Through our thermal energy storage rebate program, FPL offered more than a $1.5 million rebate to the Kennedy Space Center, the largest incentive in our company's history for installation of the thermal energy storage tank. The thermal energy storage facility can help save energy by moving and money by allowing business customers to pay lower time of use rates, as Ismail spoke of, reducing energy demand and minimizing the need to buy large air conditioning compressors to meet their cooling needs. And thermal energy storage provides the environmental benefits by maximizing FPL's usage of its most efficient power plants at night, when the least emissions per megawatt hour are produced. These facilities produce and store cold water or ice at night when power is less expensive and use it to cool buildings through the day efficiently. The results are a reduction of on-peak electric usage and lower energy bills. In fact, the installation of a thermal energy storage system can result in as much as 20 to 50% savings on an annual energy basis, taking advantage of FPL's time of use seasonal rates. FPL looks forward to continuing to partner with NASA and the Kennedy Space Center on these and other initiatives that will help advance affordable clean energy for generations to come. And I want to thank you and thank the wind for not blowing my speech around too much. And now I'm going to pass it over to Dan Clark. Thank you.
Thank you. Hopefully I'll have as much success in keeping my notes straight. My name is Dan Clark. I'm the NASA KSC Sustainability Team Lead. And one of my team's functions is to manage the energy and water resources here at KSC. Can everybody hear me okay? Am I holding this close enough? Sorry. So it was with a great deal of warmth in my heart that when I first heard about the size of the rebate that we were going to be getting for the TES. It isn't every day that $1.5 million comes your way. In fact, this was several orders of magnitude larger than any utility rebate that KSC has ever received. So the question comes, what are you going to do with that? And I have a number of people here at the Center, NASA people, and some of our contractors that have been working on that. So I'll tell you a little bit about that now. So development of a detailed spending plan is well underway. Per federal statutes, the expenditure of utility rebate money is primarily limited to energy and water conservation projects. At this time, we have identified far more energy conservation measures than we have funding for, despite the large amount of this rebate. Therefore, the team is using several criteria to whittle down the list of candidate projects that will be funded using the rebate. Because conservation measures pay for themselves via cost savings, the selection criteria includes considering how short the payback time will be and immediate environmental benefits from a given project. At the top of our list of project candidates is replacing many of KSC's external lights with amber LED light fixtures. The LEDs use much less energy than our current lights, and the amber wavelength of LEDs we've chosen is invisible to sea turtles. A Fish and Wildlife Service biological opinion being written for KSC addresses concerns about our existing external lights, the non-amber lights. In particular, the lights tend to cause baby sea turtles to become disoriented, and many of them have difficulty finding the ocean, and which makes them more prone to vulnerable to predators. An external lighting working group has been assembled, has been assessing which of our external lights can be replaced with amber LED fixtures and which lights can be removed altogether. Replacement of some external light fixtures with turtle-friendly LEDs has already begun. In the front of the operations and checkout building, you can see a few of the new fixtures in place, and there are a few other buildings as well that have them. But it's a pretty big project. We have several thousand external lights that we need to work on in relation to this project. Other project candidates for the rebate funding include interior LED retrofit upgrades in office spaces, replacing select stairwell lighting with LEDs and motion sensors that dim stairwell lights when nobody's present. We're planning for photo sensor installation and daylight harvesting, cool roof installations and HVAC upgrades. We'll be also performing facility recommissioning efforts and quite a bit more. By reducing KSC's energy footprint, we are simultaneously saving taxpayer dollars through a lower utility bill and reduced operations and maintenance needs. We're also improving the resilience of our infrastructure to catastrophic events and helping baby sea turtles survive one of the most perilous times of their lives. My wife really likes that part. Rest assured, the TES utility rebate will help KSC achieve several of our sustainability objectives and do so for many years after the money is gone. Thank you for your time. Hand it over to Brittany.
Turn it over for questions now. Somebody? Go ahead.
I'm Jim Siegel. I'm with the Celebration News and Spaceflight Insider. I have a question for that gentleman. Ishmael?
Well, yes.
Yeah, so let me see if I understand this correctly. So when this whole complex was built, there's a chiller facility. There's all these pipes going into all the different buildings. That tank wasn't there, right?
No, where are the pipes? Those are new pipes.
Okay.
Or the
yeah.
tank.
So now you put this in the tank, and so I'm curious about if that's holding 2.6 million gallons.
Correct.
How long does it take, or how many tankfuls of that liquid is used during the day for all these different buildings? One tank full, 10, 100?
No, one tank full. Since it's a closed loop system,
Yeah.
remember the water level is always the same.
Right.
And the only thing that changes is the temperature of the water. And that temperature, as the energy is discharged, what happens is at the top you have approximately 40-degree water. Okay? Then you start using it. And water is coming in at around 49 degrees at the top. Important is not to create any turbulence. So we have something called diffusers inside. So you gently and gracefully are introducing the warm water so that you continue to have what is called a stratified system. That means that there is a very, very small area where the water is changing temperatures. So you may have, 6 inches and you go from 40 degrees to 49 degrees in that 6 inches. And that's called a stratified system. Okay, so we keep it by not creating any turbulence, and you have diffusers both at the bottom as well as at the top.
All right, so let me see how I explain this. So the water is chilled here.
Correct.
In this building, and it operates more at night than during the day because the rates are cheaper, right?
Well, okay, so the hours of operation in the summer and in the winter are different. So in the summer, basically, your peak hours are between 12 and 9 o'clock. But the tank will only run approximately 5 to 6 hours before it discharges completely. Okay. At that point in time, you have to turn on chillers to actually continue to provide chilled water to the loop, throughout all these buildings, and at the same time, add cold water, chilled water, back to the tank to recharge it.
And is that during the summer or the winter?
Those hours are for the summer.
Summer, okay.
In the winter, you have 2 different windows of time, and to be sincere, I can't remember exactly. I think it's 6 to 10 in the morning is one window of time, then there's another one in the evening.
6 to 10.
6 to 10 in the evening as well?
Yeah. Thank
Okay.
you.
Hi, my name is Malia Silver. I'm from KSC. I admire your effort to have question.
Okay, in terms of trying to use renewable technology in spacecraft, well, spacecraft is a whole world of itself. Okay, so I'm in the construction business, but in the spacecraft world, it's a little bit different, no? You already have been using, for example, photovoltaics for a very long period of time, for decades, you know, for deep space missions. I was also used what they call, you know, what we call nuclear, no? As well for even further missions because of the longevity of those. Did they look at other things for propulsion systems, etc.? Yes, they do, and they always have, of course, a battery system, you know, that is a part of what the spacecraft would have. Okay, so it's a little bit different than trying to use what we use down here on Earth, but they do use those systems.
With all the new technology that's come in the past year with solar and looking at that as an option, have you thought or have there been talks about bringing that into this type of construction in order to reduce some of the wattage or costs that already takes place to run this type of thing? Yeah, sure. We're always looking for opportunities to apply renewable energy around the center. The big issue, as was mentioned earlier, is getting the funding. Renewable energy doesn't have as short of a payback, the return on investment. So one of the things, the strategies that we're doing is to try and bundle renewable energy projects with other more conventional projects like the heating, ventilation, air conditioning upgrades, and sometimes things like the TES. Now we didn't bundle the TES with anything. That was a completely separate funding stream, but we are looking at, definitely. We have, here in the Space Center, we have a small geothermal system in operation in one of the buildings that was built just a few years ago. We have another facility just north of us, well, actually about 3 miles north of us, 3 to 6 miles north of us, that is net zero energy. It tends to often puts more energy back onto our grid than what it uses. Yeah, it's called the Propellants North building. This has rooftop solar as well as solar awnings over part of the parking lot. So yes, we're always looking for opportunities to apply renewable energy technologies.
Ben, why don't you re-emphasize the microceptive campus adding that whole?
Sure. We have construction underway right now on an expansion of we have a 1 megawatt PV farm that we grow electricity, so to speak, over there. It's just about a mile or so from here, and we're in the process of expanding that by another 1.5 megawatts. The construction is well underway. A lot of the panels have already gone up, several rows of panels, and that facility is going to provide our phase 1 of the central campus. It will be net zero energy as well. I don't know if anyone told you now, Central Campus is the big construction project that's going on right next to this building. So we're pretty excited about that.
2 more questions.
Just a quantitative sort of touch on this question on your battery analogy. What's the approximate equivalent kilowatt hour storage of a full?
We can get that information to you. I can give you my card and we'll look into getting you that information.
Yeah, we don't measure in kilowatt hours. We measure more in, you know, Bart spoke about percentage, so that would be a calculation based on those percentages, and we think more about tonnage, you know, BTUs and all that stuff. So, but we can, like I said, we can answer that question in terms of.
Replacing
Well,
If I'm understanding correctly, you're thinking that this might be actually generating some energy, or?
No, not at all. You're obviously using it for storage.
Yeah.
You're chilling the water at night.
Right.
And that's storing the energy for the night.
So.
I wonder what that makes
Oh.
kilowatt hours.
Yeah. Okay, I'm with you. So yeah, we can. Off the top of my head, I can't tell you, but we can get that to you.
One more question. Anybody?
Jim Siegel again. So The rebate that of which you spoke, $1.5 million, is that a one-time rebate or annually or what? One time. And would you
Yeah,
hazard,
it's a one time. I wish it was annual, but it's not.
and would you hazard a guess as to what the annual savings of this system is at the Kennedy Space Center?
So we've calculated approximately $250,000 a year. That would give you about a 12 to 14 year payback.
All right, well, thank you, everyone.
Thanks for coming.